Imagine you're inside a cave in northern Spain, roughly 50,000 years ago, late autumn. The man sitting against the wall is in his late 20s, maybe early 30s. We can't see him. We don't have him. We have his lower jaw. And there's a hole in the bone, right beneath one of his molars, an abscess. The kind that, if you've ever had one, you've already winced thinking about. He lived in what's now called El Cedrón Cave in Asturias. He died somewhere between 47,000 and 50,000 years ago. Researchers don't know his name. They call him Adult 4. The only thing we know about his last weeks, maybe his last months, is what was trapped in the calcified plaque on his teeth on the day it stopped accumulating. His mouth held food. His mouth held the trace of a fire he'd sat near. His mouth held a small parasite that gave him chronic diarrhea. And his mouth held a pharmacy. So here's the question I keep coming back to. How did anyone heal a wound or fight an infection before medicine existed? Before pharmacies? Before doctors? Before the word medicine even meant what it means to us? The honest answer is, for most of human history, we don't really know. But for one branch of the human family, the evidence is better than it used to be. And what we now have, mostly thanks to 20 years of dental calculus chemistry and the slow rereading of very old bones, suggests they knew more than we ever gave them credit for. This video is about Neanderthal pharmacology, not metaphorical pharmacology, real chemistry, real plants, real antibiotics, and the people, yes, people, who use them. Back to Adult 4. In 2012, an archaeologist named Karen Hardy, working with Stephen Buckley at the University of York and Matthew Collins at the BioArc Research Facility, ran chemical analysis on dental calculus from 5 El Cedrón Neanderthals. The technique heats a tiny sample, vaporizes it, and reads what comes off. In Adult 4's calculus, they found two compounds that don't belong in anyone's diet: azolines, the signature chemicals of yarrow, Achillea millefolium, and coumarins, the signature chemicals of chamomile, Matricaria chamomilla. Both plants are bitter. Both have essentially zero nutritional value. Both sit in your bathroom cabinet right now. Chamomile for inflammation and digestion. Yarrow as an astringent for stopping bleeding. You might say, okay, but maybe he just liked the taste. Here's the problem. 3 years earlier, in 2009, Carlos Lalueza Fox had already sequenced the bitter taste perception gene from these same El Cedrón Neanderthals. They carried the functional TAS2R38 allele, the same gene most of us carry. He could taste the bitter. He could taste it the way you and I taste it. And he ate it anyway. Despite the abscess. Despite no nutrition. Despite the bitter. There are alternative readings. A 2015 paper from Sabrina Krief and her colleagues, comparing with wild chimpanzees in Uganda's Budongo forest, pointed out that bitter leaves can arrive in a calculus sample through prey stomach contents, or as flavoring, or as parasite control. Hardy's group replied the next year. The argument isn't settled. I read these papers several times to make sure I wasn't pattern matching. I might still be. But the simplest reading is the one Hardy proposed. The bitter plants ended up in the mouth of a sick man because they did something for him. Then 2017 happened. In March of that year, a team led by Laura Weyrich at the University of Adelaide's Australian Centre for Ancient DNA published in Nature. They had sequenced ancient DNA from El Cedrón dental calculus, not chemistry this time, actual genetic material, and from 4 other Neanderthals at sites in Belgium, Italy, and Germany. The results were already strange before they got to Adult 4. The Belgian Neanderthals from Spy Cave had been eating woolly rhinoceros and wild mountain sheep, pure steppe diet. The El Cedrón individuals had been eating pine nuts, moss, and mushrooms. Same species, completely different cuisines, separated by climate and geography. But Adult 4, the one with the abscess, was the headline. His plaque DNA showed genetic material from poplar. Poplar bark contains salicylic acid. Salicylic acid is the active ingredient in aspirin. And in the same sample, the team found DNA from Penicillium rubens, the mold genus from which, in 1928, Alexander Fleming would derive penicillin. Let that one sit for a minute. A man with a dental abscess and an intestinal parasite was, around 50,000 years ago, consuming the natural source of 2 of the most important drugs in modern medicine. 40,000 years before agriculture. 40,000 years before any culture we know how to read.
Weyrich's reading, in her own words,
Apparently, Neanderthals possessed a good knowledge of medicinal plants and their various anti-inflammatory and pain-relieving properties and seemed to be self-medicating. I keep reading that sentence and trying to find a way around it. I haven't found one yet. But there's one more piece of this I keep coming back to. Because if Adult 4 was self-medicating, he wasn't doing it alone. There's a cave in the Zagros Mountains of Iraqi Kurdistan called Shanidar. In 1957, an American archaeologist named Ralph Selecki found a series of Neanderthal skeletons there. One of them, designated Shanidar 1, has been at the center of the care argument ever since. A 1982 study by Eric Trinkhaus and Michael Zimmerman cataloged his injuries. The list, to read it out, is brutal. A crushing blow to the left side of his face, possibly costing him the eye. A right forearm amputated at the elbow and healed. Osteomyelitis of the right collarbone. A withered right shoulder and arm. Degenerative joint disease at the knee, ankle, and foot. A fractured fifth metatarsal. Many of these injuries occurred years, sometimes decades, before he died. He died between 40 and 50 years old. By Paleolithic standards, that's an old man. In 2017, Eric Trinkhaus came back to Shanidar 1 with Sébastien Villat at the French National Center for Scientific Research and looked at his ear canals. Both canals were partially blocked by bony growths, exostoses. The right canal was nearly fully occluded. The left was substantially obstructed. They concluded he would have been effectively deaf on the right, with serious hearing loss on the left. Added up. He's blind in one eye, missing a forearm, walks with a serious limp, suffers from chronic joint pain, and now he's deaf in a landscape full of large predators that he can't hear coming. There's no scenario in which Shanidar 1 survives to 40 alone. None. The simplest reading of his skeleton is that he was fed, sheltered, and protected daily for years, possibly decades. Not as a favor, as how that group lived. Shanidar 1 is not the only one. In 1908, 3 Catholic priests, 2 brothers, Amédée and Louis Buissonnet, and their colleague Léon Bardin, found a near-complete Neanderthal skeleton in a cave near the French village of La Chapelle-aux-Saints. The individual was male, in his 50s or 60s, with advanced osteoarthritis and most of his molars missing. He has been the old man ever since. There's a footnote to his story that matters. In 1911, the French paleontologist Marcellin Boule reconstructed him as a stooped, bent-kneed brute. The reconstruction, based on the arthritis Boule didn't recognize as a disease, gave the world its image of Neanderthals as hairy, subhuman cavemen. That image lasted half a century. The man Boule was looking at was actually evidence of the opposite. He was an arthritic old man with worn-down teeth who had survived into his 60s in the European Ice Age. Eric Trinkhaus reanalyzed the skeleton in 1985 and made the case clearly. This is, again, a person who could not have lived this long alone. We named a species after him. We then spent a century calling that species brutal. He was, instead, one of the strongest pieces of evidence that they weren't. So, a Neanderthal with abscess and aspirin in his teeth. A Neanderthal who lived for decades after injuries that should have killed him. A toothless arthritic man who lived to 60 in the Ice Age. The next question writes itself. Was the care strategic or was it something else? In 2018, Penny Spikins and colleagues at the University of York published 2 papers that took different cuts at the same question. The first, in the journal World Archaeology, was titled Calculated or Caring. Spikins' argument is precise. If care had been transactional, given only to those who could repay it, we should see it concentrated in productive members. We don't. We see it extended to individuals whose return to productivity is essentially zero. The very old. The blind. The deaf. Her conclusion, in her words, Neanderthals didn't seem to be calculating whether their efforts would be repaid. They were responding, she suggests, to the feeling of seeing someone suffer. The position has critics. The calculated reciprocity model, care as social investment, has defenders. The debate isn't going to resolve because you cannot recover a motivation from a bone. But the pattern of who got cared for is observable. And the pattern looks more like compassion than bookkeeping. The second Spikins paper, published the same year in Quaternary Science Reviews, made a different argument. Adaptive. Imagine a small Neanderthal group of 25 or 30 people. An adult hunter sprains an ankle. He's useless for 2 months. If the group abandons him, they lose his future hunts, his knowledge of the local landscape, his contribution to his children. If they keep him fed, he comes back. Multiply that across a generation. Groups that practiced healthcare didn't just have nicer relationships. They had more functional adults at any given moment, more accumulated knowledge held in older heads, more buffer against the constant small accidents of a hunter-gatherer life. Healthcare, in Spicken's framing, isn't a side effect of intelligence. It's a survival technology, of a piece with hunting and food sharing. If she's right, and the framing is contested, then what was in Adult 4's mouth wasn't a private medicine cabinet. It was the visible end of a much bigger system. The people around him knew which plants to bring, knew where to find them, knew what to bring next. You can't see that system in a tooth, but you can infer it. And then 2024 happened. On the morning of June 22, 2022, at a research site called Suak Balimbing on the island of Sumatra, primatologists noticed that a male orangutan they call Rackus had a wound on his cheek. He'd been in a fight, probably with another male. 3 days later, they watched him do something none of them had seen before. He climbed to a liana, a climbing vine, with the local name Acar Kuning, Fibroia tinctoria. He stripped its leaves. He chewed them. And then, for several minutes, he repeatedly applied the green juice directly onto the wound. When he was done, he took the chewed pulp and pressed it onto the wound as a covering. The wound closed in 5 days. In 2 months, it was almost invisible. Fibroia tinctoria has confirmed antibacterial, anti-inflammatory, and analgesic properties. It's used in Sumatran traditional medicine for malaria and dysentery. In a comparison of 38 regional medicinal plants, it ranked the most potent. The paper, by Isabel Laumer and colleagues at the Max Planck Institute of Animal Behavior, came out in Scientific Reports in 2024. It's the first time anyone has filmed a wild ape actively treating a wound with a known medicinal plant, which means the question we started with is, possibly, the wrong question. Because if a great ape we share a common ancestor with, somewhere around 14 million years ago, knows to put a known medicinal plant on his face when it hurts, then the question isn't, how did Neanderthals figure out medicine? The question is something more like, when, in our family tree, did we ever not know this? Adult 4 wasn't an inventor, he was an inheritor. So was Shanidar 1, in the version of him where someone brought him food for 10 or 20 years. So was the toothless old man at La Chapelle, the chamomile in your bathroom cabinet, the aspirin in your pocket, the antibiotics behind the pharmacy counter. None of these are modern inventions. They're modern refinements of a knowledge that has been with us, and was with our cousins, for longer than our species has existed. Go back to that cave, northern Spain, 50,000 years ago. Adult 4 sitting against the wall, his mouth aching. Try imagining the other thing. The person sitting next to him. The one who, when he started to grimace, said something we'll never hear, got up, and came back. Came back with yarrow. Came back with chamomile. Came back with poplar bark. Came back with a piece of mold someone had noticed worked. 500 miles east, in another cave at Shanidar, in 2020, an archaeologist named Emma Pomeroy and her team from Cambridge found another Neanderthal, in the same chamber where Selecki found Shanidar 1. They call him Shanidar Z. He'd been placed, intentionally, in a depression in the cave floor, near a prominent boulder, surrounded by bodies placed there long before him. For decades it was thought one of those earlier bodies had been buried with flowers. A 2023 paper has since shown the pollen was probably brought in by burrowing bees, so we should let the flowers go. But the bodies stayed. They kept coming back to the same place, in that cave, to leave their dead. We did not invent caring for each other. The mouth of Adult 4, the limp of Shanidar 1, the patience of whoever sat down beside them with a fistful of bitter leaves. They got there first.